Okay. Well, I have no idea why it's playing. Not sure what was happening there. Let's see if it'll let me continue. Limit as n goes to infinity. 1 minus FOIL this. N times 2n is 2n squared. N times 1 is n.
2n times 1 is 2n, and 1 times 1 is 1. That is still over 6n squared. Now we have two ways of evaluating that limit. Now actually the limit of 1 is still 1. So really all I care about is this piece. 2n squared plus 3n plus 1 over 6n squared. We could do it the old-fashioned way and say, okay, as you're going to infinity, you can divide the numerator by the highest power that's in the denominator. So n squared, n squared, n squared, n squared. 2n squared over n squared is 2. So I'm doing 1 minus the limit as n still going to infinity of a 2. N over n squared is 3 over n, and so I'm going to write that plus 3 over n. Then I have the 1 over n squared all over 6. And we know that the limit as n goes to infinity, that goes to 0. This one goes to 0. You're left with 2 6s. And so that part's 2 6s. Hold on. Let me not do this. Let me erase that part and go. That is 2 6s, but hold on. That would be 1 minus 2 6s, or 1 minus a third, which is 2/3, which is approximately 0.6666. Remember, that was our answer. So there's the answer. I was just thinking about this limit, though. Kind of interesting that if we're doing the limit as n goes to infinity of 2n squared plus 3n plus 1 over 6n squared, and it's obviously we get infinity over infinity. So we do it with L'Hopital's rule. Limit as n goes to infinity of 4n plus 3, was that what it was? 3, yeah. And then over 12n, and that is still infinity over infinity, so limit as n goes to infinity of 4 over 12, which is 1/3. So I still had my 1 over here minus the 1/3. So I still have 1 minus 1/3 is still 2/3. So L'Hopital's rule worked.